I hope it took longer to draw this picture than it took to solve the problem. So there's some kind of a bridge. Right? And, oh, where did this come from? This was 8.1, number 36. Okay, so there's some kind of bridge, and they told me that I'm able to sort of stand at this point down here, P, and look up at the bridge, and it's missing this chunk, because earthquakes or something. Apparently we're not allowed to stand on the bridge to measure how long this gap is, but we need to know. I don't know how we're going to fix it once we know, but whatever. Okay, so let's see. I know that this angle here is 35 degrees. Right, so that's me standing with a protractor, and when I look up at the far side of this gap, it's 35 degrees. And when I look at the close side of the gap, it's 42 degrees. Guys all good with this? And now I'm supposed to figure out how far D is between the 2 points of this gap. And then what else do they tell me that I need to know?
50 feet.
Yeah, they tell me it's 50 feet kind of from the bridge deck down to the level at which I started measuring, right? So that's, like, it's 50 feet from here to level, and it's 50 feet from T to P, right? So I get to use that kind of wherever I want to, but someplace here that'll come in handy, I hope. So how do you start? Where's your triangle you're trying to solve for? Yeah, there's sort of two triangles, right? There's kind of this black, obvious one, right? This guy. That's got a 35 and a 90 angle that I know of. Cool. And a side.
So it's sine of 40.
So this is a angle side triangle. You guys see that?
And because the triangle rules is technically 3A's, because you can know that the other side is 55 degrees.
Cool. Good. You guys see that? So we can know that other angle is 55 degrees. Cool. All right. Where's my other triangle?
It's along that other dotted black line.
The 42.
Yeah.
Okay. So there's kind of another triangle. That's this maybe blue one. That's this one. You see that? And that blue triangle is what? Same, different arrangement? Yeah, I think that one's also an angle side. Right? You guys see that? Is that going to be enough information for me to figure out what that distance D is?
Well, no, what's the point of hypotenuse is you can, you have that small little triangle that has like a 7-degree plane.
Oh, I could make yet a third triangle.
That's true.
And then you can use your log sine and cosine to find D. Right?
Yeah, sure. I could do it that way. I don't need to quite do that way. I could figure out what the adjacent side on the black is and subtract the adjacent side on the blue from it.
It's just a rectangle there.
You guys see that? That would give me the width of this rectangle down here, which presumably is that same distance. Or you can get out this third triangle. Yeah, totally good. There's a couple ways to do this. So let's just focus on one of the triangles, right? Like when you're not sure what to do, try something that you can maybe solve for. So I'm going to ditch the other half of the bridge, because who needs that? And I'm going to pull my black triangle out. And I know it's got a right angle, it's got an opposite side of 50, and a 35-degree angle over here.
So sine.
Okay, so sine will get me the hypotenuse, right? So what do I know about sine of 35? I know sine of 35 degrees is 50 over, yeah, whatever you want to name this thing. Sure, we can call it x. Okay, so what's x then?
Sine of 35 degrees over 50.
Ooh,
Under 50.
close.
Yeah.
So x is 50 divided by sine of 35 degrees? Somebody get me a approximation for that?
Shouldn't it be on the bottom?
Shouldn't the 50 be on the bottom? So to get from here to here, I multiply both sides by x, right? Then I'll put the x up here. And then I divide it by sine of 35 degrees.
Yeah, I got it. 87.17.
Say again, okay?
87.17.
87.17 to some kind of reasonable roundings. What are the units on that? Feet. Perfect. Alright. Why are the units feet?
Because you used feet in the
Good, because feet was what the opposite side was in, right? And sine's a ratio of side length, so it's unitless. You guys all see that? Okay, so now I know the hypotenuse of the black triangle.
Wouldn't it be easier to use tangent and solve for the side we're looking for directly?
Yeah, probably. You guys see that?
Yep.
Is it wrong to use this?
No, just.
No. Is it longer than it needs to be?
Yeah.
Yeah. You guys see that? So whatever. I'm here now, so
Pythagorean theorem?
yeah, sure. We can use the Pythagorean theorem, or we can use cosine, or we can use tangent. You have lots of options. Pick a reasonable one. I'm going to use tangent just because I just did this with sine. So tangent of 35 degrees is what? 50 over, I don't know, maybe we'll call that one y or something, right? Okay, so y is going to be tangent of 35 degrees. Ooh. 50 over tangent of 35 degrees. So I'm going to get y is approximately
71.
70,
74.41.
70 what?
What?
71.41.
71.41.
I just went to point 4.
Whatever,
So,
yeah.
yeah.
This is not chemistry class. Your roundings do not matter here. What are the units on that one? Again, C. Good. Okay. How about? Wait. So that tells me how far it is from point P to. They call this point B or something in the book, right? But I want to know the gap. So what else do I need here?
The length of the blue circle, or the blue triangle.
Good, I need to pull the blue triangle out. Okay, so pull the blue triangle out. That one's got a what angle?
42.
42 degrees. And what's the other angle, you know?
55.
Good, the opposite side's 50 feet still, right? And it's a right triangle, so importantly, right? Why is it important that this be a right triangle and not just any old triangle?
Because cosine and tangent don't work.
Good, because I want to use SOHCAHTOA, right? Which only works in right triangles. So, what do you want to use here? Which side do you want? The hypotenuse or the short one?
Short.
Okay, you want the short side? Okay, so let's do the smart thing this time and use tangent to start with. So, what do you want to call the short side here?
Z.
T?
Z.
C.
Next space.
Okay. So, what do you get for Z? Z should be
55.53.
okay, so you approximated this at 55.53. And I'm assuming you got that by thinking about
Tangent.
tangent of 42 degrees underneath 50. Okay, so what was that side length I was, or what was that thing I was looking for to begin with? D. D should be
71 minus 55.
41 minus 55.
okay. So if I want an exact answer, I'd write it's 50 divided by tangent of 35 degrees minus 50 divided by tangent of 42 degrees. You guys see that's my exact answer? And approximately, oh, I don't know, what do you get, like 16?
Close enough.
You guys cool with that? Questions, deals, things? Do I have to be worried about two possible answers or triangles here?
No.
Why not?
It's just straight.
Because it's a gap.
Just tiny.
Okay, but sometimes when I'm solving triangles, right, there's this like ambiguity. When does the ambiguity come up?
Law of science.
Yeah, when you're using law of sines to solve for an angle. You guys see that? When you're using law of sines to solve for sides, fine, whatever, no problems. But when you're using law of sines to find an angle, you have to sine inverse both sides, right? And sine inverse acts a little funny in solving triangles. Cool? Any questions about this? Where are my units? Feet.
Why?
Because that's what it's like.
That's not why. Did you minus feet from feet?
Good, because I subtracted some feet from some feet, and so of course I'm left with feet.
Because this bridge is in the US somewhere?
This
Yeah.
Sure, yeah, that's also
Could be in one
reasonable.
of the other two countries on the planet that use, what's it called?
Standard.
Imperial?
There are two countries on the planet that use imperial that aren't the
Two more.
UN.
Yeah,
What are the two more?
I don't know.
Oh,
Yeah, I think that's right.
But the only one-
Uzbekistan. No, I'm pretty sure Uzbekistan came around years ago. There are probably countries that don't have a tape measure.